Okay, guys, we're almost at the end. Last section, 1.9, about inverses. No biggie, no biggie. These are not such a big deal. 27, sketch the graph of one of our favorite friends' square root function, except move 1 to the right, 2 up. Yeah? Yeah. And then determine if it's 1 to 1 or not. I already know it's going to be 1 to 1, because of course square root of function is going to be 1 to 1, our good old friend. 1 to the right, 2 up. And other than that, so square root function means it's going to go 1 to the right and 1 up from there. And then it's going to go 4 up total. 1, 2, 3, 4. And 2 over. Right? Wait. I'm sorry, guys. I did it backwards. I meant square root of 4 is 2. Yeah, so 1, 2, 3, 4 that way. And then 1, 2 up this way like that. Yeah, square root. It's going to look like this. Is it 1 to 1? Yes, it's 1 to 1 because it passes the horizontal line test. Yeah. There's no horizontal line that goes through one more. That goes through more than one position on the graph. That means that it's an invertible function. The square root function is. But that wasn't the question. Anyway, is it 1 to 1? Yes. 1 to 1. Yes. And there's a sketch of it. And that means we're done with 27. Which means we got 2 more questions remaining, guys. Apologies if my energy has been waning here. I should have taken more breaks, but I've just been blasting through this whole thing. Okay, number 28. Let f of x equal to 2 minus 3x. G of x is 2 minus x over 3. Find f of g of x and g of f of x, then determine whether they're inverse functions or not. Remember, the requirement to be inverse functions is that if I take f of g, it's giving me x for all the x in the domain of the inner function, g in that case. And also g of f of x is going to give me x for everything in the domain of the f function, the inner function. Let's do it. What's f of g of x? Well, that's f of whatever g is, and g is 2 minus x over 3. And now what is f? F is, take that whole thing, and you say it's going to be 2 minus 3 times that whole thing. So that's going to be 2 minus 3 times the whole thing is going to be 2 minus x, right? And 2 minus 2 cancels. The minus the negative x becomes a positive x. So that part is checking out. Okay, that's looking good. What about g of f of x, though? Okay, let's see. Oh, by the way, what's the domain for g here? The inner function. Domain for g is any real number, right? Any real number, negative infinity, positive infinity. But this is true for all of those, so no issues there. Okay, g of f of x. What's that? G of what is f of x? That's 2 minus 3x. Okay, and what is 2 minus? What's g do? G says, okay, you're going to take 2 minus whatever that was, 2 minus 3x in this case, and divide by 3. So what's that? 2 minus the 2 cancels. Negative of negative 3x is going to give me positive 3x over 3. And positive 3x over 3 is just an x. So that checks out. Now, what was the domain for the inner function? Again, all real numbers. And did I lose anything? No, I didn't lose anything. This is still, the composite domain is still the same, all real numbers. It's still giving me x every time. So that means, do I have an inverse? Do I have an inverse? Yes. They're inverses. This is by the inverse function property, right? Or property of inverse functions. Yes, they are inverses. Huzzah. Last question. Last question. Thanks for sticking with me, guys. Thanks for getting this far during the whole thing. I know it's grueling at times. This is not meant to be done in one sitting like I've basically done. Okay, 29. Find the inverse of f of x equals to negative x squared plus 5 for x bigger than or equal to 0. First step here is to... Oh, by the way, it's right here. That tells me one of my future answers because I'm supposed to find the domain, right? I think so. Or at least it tells me... Yeah, it does. It tells me the domain for my original function, which is the range of my inverse function. But anyways, how do I solve inverse? First step, rewrite with a y. Right. Second step, exchange the x's and y's. And then third step, solve for y. So this is going to be, I'll move my y to the right side. So y squared. Move my x to the left. Did I say left? Did I say left and right wrong? Move the y to the left side. So it becomes a positive y squared because I added y squared to both sides. Move the x to the right side. So it's going to be negative x plus 5. Now I'll get rid of the square by square rooting. So I'm going to take the positive side of that. I'm going to get the square root of negative x plus 5. Or if you like, 5 minus x. And that's going to be my inverse function. So I'm going to say it. F inverse of x is the square root of negative x plus 5. Oh, okay. Now I'm going to sketch the inverse and the original on the same plane. Just following the directions here. Okay, original function is negative x squared plus 5. That's a translation of 5 up, 2, 3, 4, 5. Negative means it opens downwards. And it's only for x bigger than or equal to 0. So that's only this half of it. Right one, down one. Like this, yeah? That's the original function. Okay, the second function, square root function. Okay. Negative, let me write it like this so I can see the translations more clearly. This is square root of negative x minus 5, like that. Yeah, you see that? You see that? I just, why did I do that? This negative, just to confirm, if I had to distribute it, if I was to distribute it, this would give me negative x. Negative of negative 5 gives me the positive 5, right? Why did I do that though? Because this way I see the translation more clearly. This is a translation 5 to the right. Negative applied means it's going to be a reflection over the y-axis. So it's going to open to the left instead of to the right. Okay, so let's graph that guy. 5 to the right means 1, 2, 3. I should graph this point more clearly. Let's come back to this graph. Sorry, backtrack here. This was right one, down one, and should be right 2 down. 2 squared is 4, so down 4. Excuse me, this point should actually be right here. Checks. That means this is a little more. I gotta try to be a little more accurate here. It's like here. So like this. Something like that. Okay, so 1, 2, 3. Now I'm graphing the inverse now. 1, 2, 3, 4, 5 here. This is the starting position, right? But remember we saw the negative means it opens to the left. So up 1, left 1, right? And up left 4, up 2. So like this. Something like this. Okay, now remember, graphs and their inverses, they reflect over the line y equals to x. Check that out. Look, crosses right through, right in the middle, and they are reflections of each other over that thing. So that is correct. That makes sense visually. Okay, now for the domain and range part. So we did the sketching, we found it. Now I'll find the domain and range of both. So let's do them one at a time. F of x first. The domain was given to us 0 to infinity, right? From this position onwards to the right. And then the range, I can just look at it, starts at 5 and it goes down. So negative infinity up until 5. And 5 is a possibility, so it's at 5. Now that I've had that, I know without even doing any work, should be reversed. The domain is going to be negative infinity to 5. And the range is going to be 0 to infinity. But let's check. Does that make sense? Domain is negative infinity to 5 for the, let's highlight here. Negative infinity to 5 for the inverse function. This is the inverse function. Yeah, because it's negative infinity goes on that way forever, stops once it's at 5. That's right. And then the range is 0 to infinity. Well, you can get 0, yes, and then you can go upwards forever as high as you want. So yeah, that makes sense as well. So sweet. Everything works out beautifully. And that is it. Okay, done, guys. Congratulations for making it to the end. Good job, good work, good work. So let me know if you have any questions. And yeah, good luck, guys. Good luck. Good studying. If you're stuck with something, you need some extra help, just let me know.